So hello everyone, this is today's LeetCode daily question and it's 1011 capacity to ship packages within D days. A conveyor belt has packages that must be shipped from one port to another within days. The ith package on a conveyor belt has a weights of I. Each day we load the ship with packages on a conveyor belt in the order given by the weights. We may not load more weights than the maximum weight capacity of the ship. Return the least weight capacity of the ship that will result in all packages on the conveyor belt being shipped within days. So what this question is essentially saying is that we have the items which are having some weights, and those weights are represented by the array called as weights, and we have to ship those packages within d days, that is days. The variable representing days is called as days. So we need the minimum number of capacity of the ship, the minimum weighting capacity of the ship, to ship those packages within given days. So if we look at a example, we can see that we have these many packages having those weights and we have to ship them in 5 days. So how can we ship those packages? We can ship those packages in this manner, and for shipping those packages in this manner, the 15 is the minimum output, that is minimum weighting capacity of a ship. So if we send 15 ships, if we send 5 ships having capacity of 15 kg weight, then we can ship all those packets within 5 days. So you may be wondering that how can we solve this question, and first thing that will come to your mind is nothing but using a brute force way, that is just looping over the weights array multiple times. Multiple means couple of times, that is n square solution, and that solution won't pass in this question because as you can see in the constants, they are clearly given that weight's length will be 5 into 10 raised to 4, that means nothing but 50,000, and if you are doing n square, it will be 50,000 into 50,000, so it would be more than 1 in 9, and that's why this question will fail if you give the brute force solution. And the weighting capacity of a number, that means of an item, the individual elements in the array of weights will be maximum 500 and minimum 1, so they can range between 1 to 500, so you can go in that way also, but it will be a costly operation if you just go for O of n square approach. So what you can do is reduce that O of n square to something better, and what's better than O of n square is O of n log n, O of square root of n, O of n, O of log n, and O of 1. So let's try to reduce that n square to O of n log n, which is the corresponding or subsequent lower asymptotic notation or time complexity. What we can do in O of n log n? As we can see that we are looping over the array multiple times, can we do something better to just look at the array and check if the capacity is matching? If we think about n square solution, what we are doing is we were looping from the first position till the nth position, which will be the minimum. Essentially, if we were considering the weighting capacity from 1, then we were looping till the sum of the weighting capacity for each element. Therefore it was going n square, and we are also looping till the sum of that element, so it would be adding the constant time complexity to it. But if we can just think in a better way, that we were just incrementing in an n square loop, then we can clearly say that if 1 is not satisfying our condition, then 2 can. If 2 is not satisfying, then 3 can. If 3 is not satisfying, then 4 can. If 4 is not satisfying, then 5 can, and so on. But we can clearly say that if 7 is not satisfying my conditions, then any number less than 7 won't satisfy my condition of weight of the ship. Therefore, what we can do is consider that weighting capacity from the minimum weight till the maximum weight as a search space, and we know that the search space will always be sorted because it's nothing but a counting of a number from a particular number till a particular number with a difference of 1, that means 1, 2, 3, 4, and so on. And if the number is not satisfying, the lower number won't satisfy, but upper number can satisfy. And if the upper number is not satisfying, then lower numbers can satisfy. Any number greater than it can't satisfy. In this way, what we can do is we can use a two pointer approach, and that approach is what we call as binary search. So binary search is what we are using in this question. So you may think how the binary search is getting the complexity of n log n, because binary search is nothing but log n only. So let me clarify that particular thing. We are getting the time complexity of O of n log n, but it's not completely O of n log n. It's basically the time complexity of O of n into the maximum sum log. Means the O of n will be looping over the array, and then sum of all the elements of the given array, the log of that particular value. So here if you can see, we have elements from 1 till 10, and we know that sum of all the natural numbers till 10 is n into n plus 1 by 2, which is 55. And if we can just see this, we can say that its time complexity is nothing but O of n into log 55, and log 55 is clearly a constant number, so we can say that it's O of n complexity. But as the sum can grow very large, if the numbers are in the range of 500 only, then we have to be careful, because that sum can go way beyond our limits or way beyond our assumption of the sum, and that can be greater than the length of array also. So that's why on an average I'm saying it will be O of log n for the binary search, and in that way it will work. So let's code up the solution. So for the binary search, as we all know, what we need is nothing but the start and end, but before that we need an answer. So let's create the answer variable, which will be pointing to int max, and we have to return that answer variable only. After that, the start will be pointing to 0 and end will be pointing to 0. And what we are doing is we are changing the start and end pointer initially only. So you may think why we are doing that thing. But the problem with the starting point at 0 and ending point at something else will be that we can't just go from 0 till that end, because some numbers will be unnecessary to us. Suppose this is the array, and if you think that if we take a sheep of weighting capacity 1, then only 1 can fit it. If we take it of 5, then only these numbers can fill the sheep. These items can fill the sheep, and these items can't, so those items will be excluded, and we can't do that. So what we need to do is we need to take the minimum capacity as max as possible, that it can fill the smaller elements as well as the largest element of the array. So what we can do for it, we can just take it as the largest element of the array. So if we take the weighting capacity as 10, surely the all items can be filled in that sheep. So we can go in that way and just assign start to the maximum element and end to the sum of all elements, because if they have asked to ship the packages in one day only, then we have to consume all the packages in only one ship, and the size of the weighting capacity of the ship will grow in that way. So that's why if I just for loop over the weights array using this particular notation, then I can surely make start equal to max of start and weight, and my end will be nothing but it will be addition of everything, that means weight plus equal to weight. So now I have my start pointer and end pointer. Now I can just binary search, and it will be just start less than equal to end, and as we know, we just need a mid pointer, which will be equal to nothing but start plus end minus start right shift 1, means divided by 2. This operation is faster than division operation. And then we need number of days. So how many days will a ship take? So let's write a function for this. It will be a private function, and it will return an integer, and it will be called as get number of days. It will take vector of weights as input, and it will also take the capacity of the ship. and according to that we can just count the number of days. So I'll initialize my I equal to 0, I'll initialize my days equal to 0, and I'll initialize my n equal to weights dot size. I want to return the dates which I'm taking. Okay, and for processing those days, what I'll do, I'll loop till my I is less than n, and I'll keep a weight remaining equal to capacity. So my weight remaining is equal to capacity, so I have that capacity weight remaining, and while I'm looping over the array till my I is less than n and my weights of I is less than or equal to weight remaining, I'm just doing a thing which is weight remaining. I hope my spellings are correct and I'm not missing. Yeah, they are correct. So weights remaining, and then weights of I plus plus will be subtracted from it, and I'll just check. I'll check if my weights remaining is equal to capacity at this point, because it could happen that my weights remaining is equal to capacity as I have not reached that particular point where the weights of I is consumed, and if no weights of I is consumed, that means I am not adding any item to a ship, then the weight remaining will be equal to the capacity, and this is the flag that we are into a trouble, that no item is being shipped on a particular ship and that ship will go empty, and ship going empty is a costly operation and we can't take that. So therefore I'll return int max, and here I'll do days plus plus if that condition does not happen. After that, as we have this function ready, which is just giving the number of days taken if we ship the ships with a given capacity, then I'll just take this function and call it by passing the weights and the capacity as mid. This is the main point of this particular program. You know binary search, you know a code to develop to test how many days will a ship take with a given capacity, but you don't know how to get that capacity, and that capacity is nothing but a midpoint. Why it's the midpoint? Let me tell you. Suppose this is a array. Let's copy this array. Okay, so it's the array as you can see here. Now what I want to do is I want to do a binary search on it. I've told you that start will be equal to the max element of the array, so this will be start. Let's start, and what will be the end? The end will be nothing but 55 because the addition is 55. What will be the mid of both of them? 55 plus 10 is 60, and 60 divided by 65 divided by 2 is 32.5, which is 32 because we are doing the left shift, so integer is considered only. So this is the midpoint. This is the capacity of our ship. Okay, the 32 is capacity of our ship, and if you take a look at the array given, what are the ways you can ship 32 packages in a ship? As you can see, the capacity is 32, so I can add 1 plus 2 is 3 plus 3 is 6 plus 4 is 10 plus 5 is 15 plus 6 is 21 plus 7 is 28. If I try adding 8 to it, it will go beyond it and touch 36, I guess. So I can't take it, so this will be the one ship, and after that I'll take another ship and pass these items to it, so it will be 17 plus 10, which is 27. So in this way I'll pass the items, so it's 28 for this part, 27 for this part. So ships required ships required will be 2. That means if we are using one ship, then days required will be 2. And what they've asked us that a ship must require 5 days. Okay, so as ship must require 5 days to transport it, we are requiring 2 days. So what is the flaw in our program? The flaw in our program is nothing but that we have increased the capacity of the ship. As we have increased the capacity of the ship, more number of items are being placed in a particular ship on each day, and that ship is taking those items. As you can see here, 7 items are placed on a ship. On the second day, 3 items are placed on a ship. So we are taking 7 items at a time, and it's a bad signal. We have to be as close as possible and less than till days. So we can't just take 2 days only, we have to take 5 days as they have asked us to do. To take 5 days, we are using mid, that means capacity, as 32, but I have to reduce the capacity. If I reduce the capacity, my days will increase for sure. So they are not in a uptrend or not in a increasing proportion to each other. They are not in a linear fashion. So what we can do is, as soon as we encounter that our capacity, that is our mid, our capacity or that is our mid is big one and it's reducing our days, we will try to reduce our capacity so that our days will increase, and therefore this condition will arise here. That means number of days, if they are greater than the given days, in this case we have number of days given as 5, so number of days required, so here the condition is something like this: the 2 is greater than 5. This is false. So let's break over this condition and write the else part. So what we have 2 and 5. We have 2 as number of days that we are taking and 5 as number of days that we must take. What we can do now is just reduce the number of items that I can hold, that means reduce the capacity of the ship. To reduce the capacity of the ship, what I can do according to binary search is reduce my end variable till the mid minus 1, so that my capacity of the ship will be reduced. So therefore end will be equal to mid minus 1. Okay, as here we are doing end equal to mid minus 1, then what do you think will happen on this problem? This was the first iteration. I've reduced my mid. So if I write here again, my mid was 32. Now my end will be equal to mid minus 1. That means it will be equal to 31. And now my mid will become nothing but 41 plus 10, which is 51. 51 divided by 2, which is 25. So my mid will become 25, which is eventually reducing the capacity of the ship. So if the capacity of the ship is 25, then how many days will I require? 1 plus 2 is 3, plus 3 is 6, plus 4 10, plus 5 15, plus 6 21. I can't take this 7 now. Okay, so I've come till this way, so it's day 1. From 7 plus 8 is nothing but 15, and 15 plus 9 is 24, so I can't take the 10 again, so it's the second day and 10 will be third day, so I'll take 3 days. But as you can see, I'm taking the 3 days and now condition will become 3 greater than 5, which is false, and now my end will again be reduced till mid minus 1, so my end will be 24 in this case. As end is 24, my mid will be 34 divided by 2, that is 17, and if I try the same thing for 17, I can't just take this, I have to, yeah, if I try it for 17, then what do you think will happen? For 17, if I try, it will be 3, then 6, then 10, then 15, and I can't take this 6. So I'll take these elements on the day 1. On the day 2, I'll go and take 6 plus 7, which is 13, 13 plus 8, which is 21, so I can't take it. So I will take 2 days. 8 plus 9 is 17, so I can take this, and 10 will go on another day, so 4 days will be taken. But as you can see here, the 4 is also not satisfying the condition, and therefore what will happen is I'll reduce my I'll reduce my end till mid minus 1, and what was the mid minus 1 is nothing but 16, so it will be 16, and my mid capacity will be 26 divided by 2, which is nothing but 13. Now there's a catch, there's a great condition and great explanation coming towards you. That is, if I have 13 as my capacity and I'm trying to loop over these elements, so it will be 3 plus 3 6 plus 4 10 and plus 5 will be 15, so these items will go on day 1. Then 5 plus 6 is 11, 7 can't come, so day 2. 7 plus 8 What's 7 plus 8? It's 15, so they can't come, so 7 must have come alone, then 8 must have come alone, then 9, and then 10. So I'm taking 6 days. You notice something? I'm taking 6 days. As I'm taking 6 days, 6 is greater than 5. What I have to do? I have to increase the capacity of the ship so that I can reduce my number of days. So what we can do is start equal to mid plus 1, and the capacity of the ship will be increased as my start is going till mid plus 1. Mid is 13, my start will go till 14. My end will remain same. My mid capacity will change to 15. If my capacity is 15 and I am looping according to that way, then you can see that 1 plus 2 is 3, plus 3 6, plus 4 10, plus 5 15, plus 5 15 on the day 1. Okay, then 6 plus 7. What's 6 plus 7? It's 13. And 13 is less than 15. 13 is less than 15 on the second day. On the third day, only 8 will come because 8 plus 9 is 17. So it will be third day. It will be third day. The 9 will come on the fourth day, as you can see here also. And 10 will come alone on the fifth day, as you can see here. So it will take 5 days. As it has taken 5 days and I know that 5 days are taken, I can say that I can take less number of days than 5 days, or I can say that I can take 5 days only but reduce my capacity. And to reduce my capacity, I am again going to else condition and going to do this minus wala thing. So my end will become mid minus 1. Mid minus 1 is 14, so it will become 14. This will become 14. Now how many days will I take? What do you think? I'll take 6 days. I'm not calculating all over it again, and if you just want me to calculate, let's do it. So it's 1 plus 2 is 3, plus 3 6, plus 4 10. 5 can't come, so this will be day 1. Then 5 plus 6 is 13. This will be, it will be 11, not 13. It will be day 2. Then 7 plus 8, they can't come, so this will be day 3, this will be day 4, this will be day 5, and this will be day 6. In this way I'll take 6 days. As it's greater, I'll increment my start, and as soon as I increment my start, it will become nothing but 15. And I can't calculate my mid because my for loop, my while loop will exit as the condition is not being satisfied. In this way we are doing this. But you may ask that we are returning the answer, then where we are updating the answer? So what do you think where we can update this answer? If you think carefully about this problem, we are pretty sure that we got the least number of weight that we have to go ahead with when we are reducing our end. So therefore we can update it here. Answer will be equal to mean of answer and mid. Okay, so as we are updating it here, let me give you one more example having an edge case. Suppose this is our example. Let's draw this here, and let's take this template because I'm too lazy to write all the things. What do you think will be the start? The max element, for sure it will be 3. What do you think will be the end? The sum of all the elements. 1 plus 2 is 3, plus 3 is 6, plus 1 7, plus 1 8. What do you think will be the mid? The addition is 11. 11 by 2 is 5.5, so it will be 5. How many days will you require? Let's dry run the condition. Okay, we will require, at the capacity of 5, we will require 1 plus 2 is 3. I can't take this 3, so this is 1 day. I'll take this 3, this one. I'll take 2 days. I took 2 days. I must take 4 days. Okay, let's write the days equal to 4. I must take 4 days. Can you see the condition? 2 and 4 not satisfying. We go to this block. Okay, as soon as we go to this block, our answer was set to int max here. Now that the mean of int max and 5 will be 5 for sure, so my answer will be equal to 5. But as you can see, we can just do better. We were taking capacity of 5, but the number of days are lesser than the days required, so we can just reduce the end, and this can be our answer. Okay, the 5 can be our answer, but we try to do better. As we are trying to do better, we are reducing the end to mid minus 1, which will result in end being 4, and now the mid being 3. Okay, let's do this on the next line. My start will be that thing only, end will be mid minus 1, which is 4, and mid will be 3. Now if I consider 3, what I can do? 1 plus 2 is 3, 1 day, this 3 second day, this 2 third day. I'll take 3 days. Okay, if I am taking 3 days to do this particular thing, then what do you think will be the answer? Answer will be 3 for sure. Okay, but is this going to be a real answer? If it will be 3, then my answer will go in that way, and my answer is 3 now. But we can say that 1 2 3 and 4, in this way we were going, but the answer is 3 because 3 is the minimum days. And if I consider this again like this and I reduce my mid, it will be 3 minus 1, which is 2, and the loop will end. The answer will be 3 only. They were asking us to take 4 days, but we took 3 days, and it's valid. It's absolutely valid because as we are taking 3 days, or the capacity of ship must be 3, we can take 4 days. Okay, let me explain this again. Sorry, I have this array. The capacity of my ship is 3, so I can go in this way. There are a number of ways. I can go for the day 1 like this, for the day 2 like this, for the day 3 like this. Okay, I can also go for the day 1 like this, for the day 2 like this, for the day 3 like this, for the day 4 like this, in 4 days. I can also go for the day 1 like this, for the day 2 like this, for the day 3 like this, for the day 4 like this. So these are the ways I can go. So therefore the capacity can be 3, so the days can be increased. They can arrange their ships in any way, but including or maintaining the order. So that's why our answer will be correct for this test case also. So let's try to submit this answer. And yeah, it's working. Let's submit it. And we have already discussed the time complexity of this problem, and space complexity is not that much. We are not using any space at all. So I hope you understood the solution. If you understood the solution, just like the video, share this video with all your friends who are stuck up in this problem, and don't forget to subscribe to the channel because such videos are coming on the channel every day. And don't miss to see my dog Luffy on the shorts of this channel. Thank you very much. I'll see you in the next one.